Thank you for watching my video. Today I'm going to talk about scalability. Scalability is a challenge in many areas. So wherever you have a lot of data or users or processes or a lot of something, you need to think about scalability. So for example, in system design, data engineering, machine learning, and so on, in all those areas, you have to constantly think about how to scale. And the goal of this short video is to give you a mental model of scaling. So if you have never thought about this before, then by the end of this video, you will have the first mental framework that gives you the ability to think about scaling. So you may have heard this before, this expression, this does not scale. So the question is, what does this actually mean? And let me give you a very simple definition. Something that worked with little does not work with a lot. And in here, the something could be an application, could be a website, could be a manual process. And the little and a lot, this could be data, users, or clients, or many other things really. And the question now in this definition is, what does work mean here in this context? And this has two sides to it. So for one, you want to have a correct result. That's the bare minimum to say something works. However, quite often that's not enough. You also need this result fast enough. So let me give you an example. Let's say you want to place a bet. There's a game or a race starting in 1 minute. So you go to your favorite betting website and you place your bet. Now you want to, for sure, be confident that the details of your betting, the team and the horse and everything, that this is all correct. But if the response takes more than 5 minutes to get back to you, then this service does not really do what you expect it to do. So what we then actually want when we say something works is we want that it works reliable. And so what we call reliability here. So the system should always return the correct result. That's the bare minimum. But it should do so even under adversity. So if there's a hardware failure, let's say once a server goes down, you would still expect the betting website to function and give you the service you expect. And not only that, it should also always have a sufficient enough good performance. So what then does performance mean? At a very high level, what performance influences are two things. So there are the resources on one side of your system. This could be your servers and all the details that of the programs that in the application that run on it. And on the other side, you have the load. And normally what happens if you increase the load and the resources stay the same, the performance goes down. So, and what you expect then to do when you talk about scaling is you want to make sure that with increasing load, your resources scale in a way that the performance stays the same. So now let's talk about load then. So what is actually load? And this very much depends on your architecture. So it could be something very simple and you say just the number of users in your system determines your load. But in many cases, this is probably just too broad to really be useful. So you may have to go into more detail. So then you may say, if you have lots of events in your system, it could be the size of the event queues. If you scale services up, it could be the number of service instances. It could be, if you cache data, the number of cache misses, or something like database reads versus database writes that determine the load in your system. So with this in mind, what we define here is we get a set of load parameters that are useful for a system to describe load. And once you have these parameters, you are then able to scale your resources in an automated way, which is also called elastic scaling. Sometimes you can also just scale manually, just make the server size bigger, for example. That might work in your case, but what you usually want is an automated way to scale. So we have described now the load side. Let's now talk about performance, because we also need to measure the performance to make sure that the scaling actually works. And this again depends on the system you have. You may use something like throughput. So if you have a photo website, just the number of photos you can upload per second might be the measurement. Or if you have a website, then how many requests per second can this website handle, and in what response time do these requests get fulfilled. But this usually, when you talk about performance, it's usually not one data point. So what you actually quite often want is to see the performance over time. And so let's say here we have a number of requests that happen along a timeline, and each request takes a different amount of time. So how do you measure this then? And what is quite often used is a percentile measurement. And so for example, the median, which is called a P50 percentile, this means that 50% of the requests are faster and 50% of your requests are slower than the median value. So this gives you a broad overview of the performance of your system, but it does not tell anything about every user, and it does not consider the outliers. So if you look at this here, this is very much ignored in this measurement. And it might be, depending again on the system you have, that this does not matter very much to you, but quite often it does. Because let's say you have a shopping website, it's very likely that this client here is someone who has a very full basket, and that just this one takes very long. So it's actually your most valuable client, and you want to make sure they have a good experience. So you go usually for a much higher percentile to measure the performance. And when we say like a P95, then we know that 95% of our requests are below this and 5% are above. So now we have talked about load and performance. The question now is, how can I actually improve the scalability of my system? And there are, very roughly speaking, just two ways to do this. So one is you just get more resources. And there are two ways to scale. There's the vertical scaling, where you just give a bigger machine, let's say, to your system. And if you have a small server and you put your application on a bigger server, it will behave better. This, of course, has a limit, because there is a limit to what the server can handle. What you then usually do is you scale horizontally, where you put more resources in your system, let's say more servers. However, also this, first of all, requires that your application can scale horizontally. And secondly, both type of scaling still have a ceiling, and you may be at a point where you can actually not scale better than what you have, or it could be that you incur so high cost that it's not very efficient what you're doing. So if that's the case, then there's only one other way to improve scaling, and that is you need to change the architecture. That's something that always happens. When you ever go like a magnitude of load more in your system, you usually need to refactor your architecture and improve in a way that you can handle the load. And this is very specific to your architecture. There is unfortunately no silver bullet. You cannot just put more scaling on a system and it works. Yeah, there are many things. This is the whole subject of system design. So you could do caching, batching, indexing, and so on. But yeah, as I said, there is no silver bullet, and this is really something then to continue. So having said all that, let me now come to your first mental model of scaling. So performance is determined by load and your resources. You measure your load with the load parameters. You measure performance by, for example, a percentile metric. With these load parameters, you might be able to scale vertically or horizontally, and you may do this manually or in an automatic or so-called elastic way. However, there's a ceiling to it usually, and it can be also a cost reason that it just gets too inefficient. And at this point, you just need to change the architecture. And yeah, and that's it. I hope you found this useful. Thank you very much.